So, causal studies or causal research studies. We can go through several of these. So again, there's many ways to compare groups with causing distributions or normal data that is distributed in a normal way and that have enough people in their samples. So we can compare one group to a standard, which is called a one sample t-test. We can compare two groups on a score, which is called an independent t-test. We can compare more than one group on a score, which is analysis of variance. We can compare more than one group with something called confounding variables, which is analysis of covariance. And there's some others that are mentioned in the book. These are the ones I want to focus on. If the data is not normally distributed, or if it has small numbers, or if it is ordinal data, I already said that, if it's not normally distributed, if they don't satisfy one of those four key conditions in the other presentation, then we have to use non-Gaussian distributions. So we can compare groups when the data is frequency counts, which are called chi-squares. We can compare two groups with ordinal or non-Gaussian data, the Mann-Whitney U. We can compare more than two groups with ordinal or non-Gaussian data. So just like if we want to compare two groups, this right here, that's the independent t-test. Also, it's also called the unpaired t-test. The non-Gaussian version of that is the Mann-Whitney. So everything has a version to it depending on what the data looks like. So let's get a little more specific about some of these. So one sample t-test. Let's say we want to compare our group to some identified standard. So for example, let's assume for a minute you think that you have an exceptional high school freshman class, and we want to compare their scores to the average PSAT score. To do this, you're going to need all of their scores. You have to remember that it's not enough to simply say, well, we've got our PSAT scores and they have a mean, and we can compare it to the national mean for PSAT and have that mean anything or indicate anything. That's not enough because you don't know the standard deviation or distribution of your scores in relation to that. Even though they might have the same means or similar means, there might actually be a significant difference. Then again, there may not be. It's entirely possible that your mean for your group is actually higher than the PSAT average, but there's just a few really, really exceptional students that are pulling that score up. And actually, the distribution is relatively the same. You can't know without checking that. Another thing that you can do is if you want to compare two groups on normally distributed scores, we can do that, but we have to assume those two groups are equally distributed in all other aspects. So for example, we might want to compare the third graders at one school to the third graders at another school. But that doesn't mean that the third graders at one school look like anything like the third graders at the other. And if they don't, then you can't say that there's any difference between the two, even if you run the test, because the groups aren't the same. You don't want to be in a situation where someone could say that you have a difference, but how do you know it wasn't X instead of Y that you compared? How do you know it wasn't ethnicity? Or how do you know that it wasn't gender? Or how do you know it wasn't socioeconomic status? All that being said, the way to compare two groups is an independent samples t-test or an unpaired t-test. And we saw an example of how we could do this at the beginning of the course with the book club data, where it compared those in the book club to those not in the book club. And one time that we did it, we saw a difference. The other time we did it, we didn't see a difference. And that's why you have to be able to run the test. Because again, just like this, it's not enough just to have the means. You have to know what the standard deviations are. Another example is something called an ANOVA, an analysis of variance. This is where we want to compare multiple groups. So let's go back to the PSAT scores. Let's say we want to compare our three high school freshmen on PSAT scores. again, we need to have their actual scores. We know there's some variance within the scores of each high school, but what we want to know is this, is does the variance in one or more high schools exceed that of the other? So there's variance within and there's variance between. We want to know if the variance between the high schools is greater than the variance within any one of the high schools. So it could be that high school A has a significantly higher PSAT score than high school B, which is equal to high school C. So it may be that these two are equal, but this school A is actually higher than these two. It could be that high school A is better or has a higher score than high school B, which has a higher score than high school C. It could be that high school A is equal to high school B is equal to high school C. There is no difference in the scores. We don't know, and we can't know until we run an ANOVA. And here's the thing, is this part of it, we don't really know with just an ANOVA. An ANOVA will tell you if there is a difference, but you need something else called a post hoc test to tell where the differences are. So in essence, what I'm saying is ANOVA will say, yes, there is a significant difference in high school A, B, and C. But to be able to know this part takes something called a post hoc test. Right now, that's all you need to know, is you have to have a post hoc test to determine where the differences are. How to actually do this and where the data comes from, you'll learn this fall. You actually be running your own data this fall. ANOVA, analysis of covariance, is used when we think that some other variable might interfere with what we're measuring. So thinking back to what I said about the third grade students and their socioeconomic status, we might want to know if there's a difference in the scores between those two schools, but maybe their socioeconomic status compounds that. So again, with this PSAT, it's possible that gender or ethnicity compounds the difference between the PSAT scores. So for example, the freshman girls at all three high schools may have higher scores than the freshman boys. In addition, there may be differences between the high schools as well as with gender added. So for example, we might see that the high school A girls, that is the girls that go to high school A, might have higher scores than the boys who go to high school A. But the high school A girls also have higher scores than the high school B girls. This is a very complicated situation and can only be really determined by using an analysis of covariance. And you only do something like this if you think that there's a possibility it may be an issue. So that, again, that's why you do a decent lit review and you do some background work to determine the extent to which these covariants may be interfering. So the non-parametrics. Chi-squares are used to compare categorical or dichotomous data between two groups. For example, we might want to know how gender and smoking interact. So we have two options for gender, at least for this example we do, and two options for smoking. You're male and female, and either you smoke or you don't. And we want to know if gender has something to do with smoking. I want to show an example of this in a minute. A Mann-Whitney U. Again, if we have non-normal distributions, small groups or survey data, and this is the most common time I see this being misused, we need to use a different test. In this case, we want to compare two groups on a score if they meet the non-normal condition, or small group, or if we have ordinal data. And what a Mann-Whitney does is it uses rank comparisons to determine significant differences between the two groups. For example, it would take each person's survey, and you think back about a survey, it has a score of 1, 2, 3, 4, or a score of 1, 2, 3, 4, 5. If you have a total score on that, on your perception of job satisfaction, and your score is a 1, and you're a male, and all the other males have 1s and 2s and 3s, and all the females have 4s and 5s, then what this will do is determine, yes, there's a difference between males and females based upon what their ranks are. It'll actually take the scores and rank them. And the last one we're going to hit on is the ANOVA. So just like an analysis of variance, we can compare multiple groups of non-normal distributions. And again, the computer is going to rank the participant data and compare those ranks based upon additional criteria. So for example, if we want to compare job satisfaction with elementary, middle, and high school teachers, you have three groups. You can run a Kruskal-Wallis and it will compare the ranked data of those three groups to see if more of the elementary score higher, more of the middle school score in the middle, and more of the high school score lower. It won't tell you, it will tell you if there's a difference. It won't tell you where the difference is. So what I'm going to do is I'm going to go through some examples of each of these tests and show you what the data looks like.